let's go ahead and start the session 3 of our chapter 18, and we will see how we can chemically change a substituent on the benzene ring. Now you guys know how we can add alkyl group if you want to rearrange product, or if you want the straight chain, how we can add on to the benzene ring. Now we can further change this alkyl group. Okay, so the bromination. So the bromination you can do in two ways. One is a free radical bromination. You can add a bromine with H nu. H nu is a photon of light. So this is a free radical mechanism. Bromine will be radically cleaved, having one radical. And basically this carbon, which is the benzylic carbon, one of the hydrogens on the benzylic carbon will be substituted with the bromine. Free radical substitution. I think you studied this mechanism in organic 1. Okay. Also we did one of the experiments having primary, secondary, tertiary places brominated in the presence of the light, and see which one gives you the most fast reaction. So the benzylic position, the advantage is once the free radical is formed, that is going to be resonance stabilized with the benzene ring. So that is why always when you have a long chain like this, it's this carbon, the hydrogens on this carbon is going to brominated. Okay, so none of the other hydrogens get brominated, but it is the benzylic carbon. Okay, for the reagent we use bromine and a photon of light. Another way, if you have toluene, NBS is N-bromosuccinamide. In the presence of a peroxide and heat, you can brominate the benzylic carbon, CH2Br. Bromine selectively substitutes for a benzylic hydrogen in a radical substitution reaction. Okay, you guys remember the benzylic position, which is this position. The phenyl is this part, benzylic is this carbon. Okay. Substitutions at the benzylic position. Now let's say you take your toluene, react with N-bromosuccinamide, NBS and peroxide, you form this benzylic bromide, benzyl bromide. Okay, you want to do furthermore reactions on that position. What you can do is with a hydroxide. Okay, hydroxide will give you an alcohol, benzylic alcohol. A halogen at the benzylic position can be substituted via an SN2 reaction. Okay, because it's a primary carbon over here, SN2 hydroxide attack the carbon, leaves bromide, benzylic alcohol. And a cyanide, with the cyanide, it can again in SN2 fashion can add a cyano group on the benzylic carbon. With ammonia, you can have ammonium group attached along with the bromide, and when you add a base, so the bromide and then excess hydrogen will be lost to give you a benzylamine. Okay, so these are some of the reactions that can undergo at the benzylic position. Elimination at the benzylic position. Now when you add a base, a bulky base could be like a tertiary butoxide, right? So they would not normally participate in the substitution reaction. Instead, it would eliminate HBr, hydroxide, a base, a bulky base, or ethoxide or alkoxide. Okay, alkoxide molecule or ion can take the hydrogen from this carbon and then eliminate HBr to give you unsaturated product. Okay. Bulky base encourages elimination over substitution. I was trying to remember the name of this molecule. Is that styrene? But don't worry about it. Okay. Unsaturated substituents can be reduced. Now once you form this molecule, unsaturated compound, you can use a catalytic hydrogenation to reduce the double bond, but not the benzene ring. Okay. And a cyano group can be reduced using Raney nickel, another hydrogenation catalyst, to give you CH2NH2. If you want to reduce the benzene ring, we need to use harsh conditions. So you can use hydrogen, gaseous hydrogen, with a nickel. You have to heat it up to 250 degrees Celsius and the high pressure, 25 atm. Now what is the normal atmospheric pressure? It is 1 atm. Now 25 atm is a high pressure. Okay. At high pressure and high temperature with nickel and then the hydrogen, you can completely reduce the benzene ring to cyclohexane. And these alkyl substituents we can oxidize with chromic acid all the way to carboxylic acid. You cannot stop it at aldehyde over here. Okay, so toluene, this methyl group with chromic acid, heated chromic acid, can give you carboxylic acid. So this is benzoic acid. And here also you can see here you have a straight chain. You have here also rearranged product or maybe a substituted alkyl group. Okay, secondary alkyl group and a primary alkyl group. So it doesn't matter what is the kind. When you heat it up with chromic acid, both of these chopped and give you carboxylic acids. Okay, and this oxidation can be done if the benzylic carbon carries a hydrogen. You see here, this is the benzylic carbon. There are two hydrogens. Benzylic carbon, there is one hydrogen. Okay, if you have a tertiary carbon group here, then you will not be able to do this process. Okay, you need to have a hydrogen on the benzylic carbon. So this also have a hydrogen on the benzylic carbon. Now for example, here you have a tertiary carbon attached to the benzene ring. It does not have a benzylic hydrogen. So with chromic acid, no reaction. Because in the first step in the oxidation reaction is a removal of a benzylic hydrogen. We don't have to go through the whole mechanism, but the chromic acid oxidation loses a hydrogen from this carbon, first step. But this one does not have that hydrogen, so it will not undergo oxidation. A nitrobenzene, if you have a nitro group attached to a benzene ring, you can reduce it to NH2 group using a catalytic hydrogenation, palladium and carbon. Alright, so now we're going to look at di-substituted benzenes and how are we going to name them. Now here you have two bromo groups, so you can say 1,2-dibromobenzene. Excuse me. 1,2-dibromobenzene. Or you can say ortho-dibromobenzene. Ortho-dibromobenzene. Ortho position. So if you consider this as your main group on the benzene ring, this position is called ortho position. Ortho. This is a meta and this is para. So you can say ortho-dibromobenzene. So this one you can say either 1,3-dibromobenzene or you can say meta-dibromobenzene. Meta to this bromine, there's another bromine. So meta-dibromobenzene or M-dibromobenzene. So this is in the para position. 1,4-dibromobenzene or para-dibromobenzene. The relative positions of two substituents can be indicated by numbers or by prefixes. Numbers would be, this is number 1, 2. So it's 1,2-dibromo. 1, 2, 3. 3, 1, 3-dibromo. 1, 2, 3, 4. 1, 4-dibromo. Or you can say ortho, meta, para. Ortho is the adjacent one. Meta separated by one carbon. Para opposite each other. Okay. Excuse me, sorry about that. So how are we going to name di-substituted benzenes? Excuse me. Here you have a chloro group and an iodo group. 1 chloro, 3 iodo benzene. Why do you put 1 on chloro and 3 on iodo. The substituents are listed in alphabetical order. So chloro, C comes before I. So we give number 1 to chloro. So because then your substituent alphabetical order and the numbers also will take precedent, right? The correct order. 1 chloro, 3 iodo benzene. Or you can say metachloroiodobenzene. Excuse me. The first mentioned substituent is given the 1 position. The ring is numbered to give the second substituent the lower possible number. Okay, let's continue. So this one, you have a bromo group and a nitro group. B, alphabetical order, B comes before the N. So there would be 1 bromo, 3 nitrobenzene. Metabromo-nitrobenzene. Metabromo-nitrobenzene. And for this one, 1 chloro, 4 ethyl, CE. 1 chloro, 4 ethyl benzene. That would be parachloroethylbenzene. Parachloroethylbenzene. Metabromo-nitrobenzene. And then the metachloroiodobenzene. The substituents are listed in alphabetical order. The first mentioned substituent is given the 1 position. First mentioned one. The ring is numbered to give the second substituent the lowest possible number. For example, instead of going 1, 2, 3, 4 like that, if you go from 1, 2, 3, 4, 5, this will take 5, right? Instead of 5, you go by 1, 2, 3 like that. Excuse me. So this one, 4-nitroaniline. Common name for this group is aniline. So 1, 2, 3, 4, 4-nitroaniline. Or you can say para-nitroaniline. This is ortho-meta-para-nitroaniline. And this one, 2-ethylphenol. So this group, this whole compound is phenol. So on the second position, you have ethyl group, so 2-ethylphenol. Or you can say orthoethylphenol. Ortho position, there is ethyl group. And this one, methyl group, is number 1. So this is 2. So 2-chloromethylbenzene or orthochloromethylbenzene. And this one, 1,3-dimethylbenzene or metaxylene. Some substituents can be incorporated into a name. Like NH2 with the benzene ring is called aniline. OH with benzene ring is phenol. Okay, like that. An incorporated substituent is given the number 1 position. With the second substituent, methylbenzene is used rather than toluene for this one. Methylbenzene. If you have a second substituent, 1,3-dimethylbenzene. Normally this ring without this methyl group is called toluene. But when you have 2 methyl groups, you would rather say 1,3-dimethylbenzene or metaxylene is the common name. Another one, so this one is orthotoluidine, methyl group and NH2 adjacent to each other. So this one, since this is in the ortho position, okay, so remember without the NH2 group, this is toluene. And since ortho position you have an amine group, it is called orthotoluidine. So this is called metaxylene and this is paracrisol. Some disubstituted benzenes have both substituents incorporated into the name. So these are examples of those.